Si Sheila. Okay. So, in the previous meeting class, we have learned some vector operations. Atong na-learn class kay vector addition, vector subtraction, multiplication. So, for vector multiplication, we have three. So, scalar multiplication, wherein we multiplied a scalar quantity to a vector quantity. So, we will often do that in electromagnetism. And then also, we have the dot product or the scalar product and the vector product or the cross product. And we have also learned some of its properties, such as, so ganito, the dot product is commutative and it is also distributive. But the cross product is distributive but not commutative. So in determining the magnitude and direction of a cross product, we should use the right-hand rule. So in determining the direction, we will be using the right-hand rule. Okay. So let us now discuss. Okay, let us discuss. Makita ninyo class?
Yes, ma'am.
Okay. So we have the component form. So we have the component form. So if we let x hat, y hat, z hat be unit vectors, are you familiar with unit vectors?
Yes, ma'am.
Yes, ma'am.
Okay, so siguro ang atong na-learn is katong I hat, j hat, k hat. So this are similar. So your x hat is actually your I hat, y hat is j hat, and then k hat is your z hat. So let x, y, and z hats be unit vectors parallel to the x, y, and z axis. Okay. So vector A, if you have a vector, it can be expanded into its component form. So vector A, or you can write it as this, it can be expanded. So suppose it is a three-dimensional vector. So you have A is equal to A sub x, x hat, plus A sub y, y hat, plus A sub z, z hat. Okay? So here, AX, AY, and AZ are called components of vector A. So again, A sub x, A sub y, and A sub z are called components of vector A. Okay. Now, geometrically, the components are the projections of A along the three coordinate axis. So, we have learned no nga ang x component is its projection along the x-axis. The y component is its projection along the y-axis. Tapos, nadugangan lang ng z component. So, if it is a three-dimensional vector, then it has a z component. So, this is the projection of the vector A along the z-axis. Okay? So we can now reformulate our vector operations. So let us reformulate the vector operations. So sa ganitong mga vector operations, so we have vector addition. So for vector addition, we have A plus B is now equal to, since vector A can be represented as this, A sub x, x hat, plus A sub y, y hat, plus A sub z, z hat. We will add this to B sub x, x hat. So this is vector B, plus B sub y, y hat, plus B sub z, z hat. Okay. Now, in adding vectors, you should add like components. So for example, a sub x and b sub x are both x components. So we will add it. So you have a sub x plus b sub x. I-add lang nato ang like components. Plus a sub y plus b sub y, y hat, plus a sub z plus b sub z, y hat. Okay? So this is vector addition now. So rule number one in adding vectors, to add vectors, we should add like components. Add like components. Okay. So this one is very easy to remember. Okay. And then how about multiplication? Now, for multiplication by a scalar, so we have, di ba naatay ing ani, no? A multiplied by vector A. For example, this is scalar. We cannot call this scalar multiplication because scalar multiplication is dot product. So this is multiplication by a scalar. So in multiplication by a scalar, so ang geto siya class, we have A multiplied by A sub x, x hat, plus A sub y, y hat, plus A sub z, z hat. Okay, so this is your vector A. This means that all of the components kay ma-multiply kay scalar A. So you have A sub x, x hat, plus A multiplied by A sub y, y hat, plus A multiplied by A sub z, z hat. So this one. So rule number 2, for multiplication by a scalar, rule number 2. So to multiply by a scalar, multiply each component. Okay? So take note of this. Multiply each component. All right. Now, for the third rule, it pertains to the dot product. So rule number 3. Rule number 3 states that to calculate dot product, so if we calculate the dot product, we have to multiply like components. So multiply like components. So for example, if we multiply A dot B, so get to answer basta dot product, we will get a scalar quantity. So if we have A dot B, we know that A can be expressed as A x hat plus A y, y hat plus A sub z, z hat, right? Okay pa mo dira, class?
Okay ba ma?
Okay. We have B sub x, x hat. I cannot see you, so I would like you to kanang mo storya lang mo from time to time. So, tanon lang ta mo from time to time, class, para kabalo pa ko nga naapa mo dira. Okay. So for this, multiply like components. So you have A sub x multiplied by B sub x. So take note that we will get a scalar quantity out of the dot product. So we have A sub y multiplied by B sub y plus A sub z multiplied by B sub z, and then i-add lang din ni siya na to, class. These are just numbers, so we can add it algebraically. Okay? Now, why is this so? Ano ganito? Because kung nakadumdum mo, I dot I, or this is equivalent to x hat dot x hat. X hat dot x hat is just equal to
1.
1, no? Kay unit vector, this is equal to AB cosine theta, AB cosine theta. So, ato ang A ay ang magnitude kay 1, mo man atong vector A si x. Basta unit vector, ang sagay ito yung magnitude 1. So, you have 1 multiplied by 1 multiplied by cosine theta. Since they are equal, meaning the angle between them is 0, no? E, parehaman sila. Right? Hagay ng x, parallel sa x-axis. So, naadiri si x, for example, yung magnitude kay 1. Basta unit vector class, yung magnitude is 1. And then, since they are parallel, the angle between them is 0. So, you have, this is equal to 1. So, the same with y dot y. Y dot y is equal to z dot z hat. This is also equal to 1. The same reason. So, actually, kay imo na siyang ikuan class, imo na siyang i-distribute. So, imo na siyang murag FOIL method gani. But when you dot, dili pareha nga components, like for example, x dot y, like this one, ax, x hat, dot bx, by, y hat, this will become 0. Kaya nga no ganito, unit vector, ang magnitude is 1 multiplied by 1, and then you have sine 90 rather. It's sine 90 degrees. This is equal to, sorry class, since this is dot product, this is cosine 90 degrees is equal to 0. So when you dot perpendicular vectors, like this one, they are mutually perpendicular. The x, y, and z hats are mutually perpendicular. Therefore, when you get the dot product of these unit vectors, you will get 0. So you have, for example, x hat dot z hat. This is just equal to y hat dot z hat equal to y hat dot x hat. This is equal to 0. Okay? So that ang mahabilin na lang at terms class kay kini na lang silang tulo. Okay? Follow ra?
Yes, ma'am.
Yes, ma'am.
Okay. And then, for example, if you have a dot a, particularly, if you get the dot product of a vector by itself, so you have a dot a, for example, so you will get ax squared plus ay squared plus a sub z squared. Or this is just equal to a squared. So this is somewhat familiar. Mara na siya o katong Pythagorean theorem with kining addition lang aning the z component. Okay. Now, for example also, if you get the dot product of a vector, so for example, you get the dot product of A with any unit vector x hat, y hat, and z hat, ang imong makuha is the component of that vector along that direction. So for example, kung A, i-dot nato sa x hat, ang atong makuha is the x component of A. So this is equal to A sub x. Okay? So, ano gani ni? Na-imagine na ninyo class? So, ipakita ha nga ng A sub x. So, you have x hat, A sub y, y hat, plus A sub z, z hat. So, this is your vector A. I-dot na to kay x hat. Okay, so these terms will vanish, no? Kaya wala man siya y hat o z hat diri ah. So, we will be, ang atong makuha is, if we dot any vector with a unit vector, ang atong makuha is the component of that vector along that direction. So in this case, ato nakuha kay ang x component ni A. So the same with dotting A with y hat. So we will get A sub y. And then A dot z, we will get the z component. Okay, so that is rule number 3. And then for rule number 4, it pertains or it talks about the cross product. So to calculate the cross product, let me just write it. To calculate the cross product, so we have to form the determinant. So again, a determinant class. Are you familiar with the determinant?
Ano sa matrices, ma'am?
Okay, so sa matrix. So whose first row, ang first row sa atong determinant is the unit vectors. Is the unit vector, so nakay x hat, y hat, z hat. Okay? And then second row are the components of A. Kabalo naman siguro gid maano eh. Components of A. And the third row are the components of vector B. Okay, so we have this one, meaning to say, when we get the cross product of A and B, so we have A cross B, this is equal to the determinant of the matrix, wherein the first row is the unit vectors x hat, y hat, and z hat. And then the second row are the x, y, z components of the first vector. In this case, it is vector A. And then we have the last row is the component of the second vector. In this case, it is vector B. Okay? And then, so ang ganun siya, use basket method. Right? So you have AY minus, AYBZ minus AZBY. So this is the x component of the dot product, the cross product rather, plus the y component, which is AZBX. Is this correct, class? Sakto, no?
Ma'am. Ito, ma'am.
Yes, ma'am.
And then we have AXBZ. This is the y component. And then the z component is, I think this one, AXBY. AXBY minus AY B sub x. So this is the z component. So, unsa ito siya nga method, basket method, mangguro ang tawag ani class. Okay, so usahay maglibog ko ang akong buhaton kay mag-add ko diri og x hat, y hat, kini copy na ko ning first and second row diri para ana-ana din ko class. Kini siya minus ana. Kini po siya minus katong y diri. Okay? So, that's it. That is rule number 4. Now, we have here an example. So, example. Find the angle between the face diagonals of a cube. So the cube has side equal to 1 unit. So, okay. And the cube ang iyang corner, the cube has side equal to 1 with one corner at the origin. So, sige to. Find the angle between the face diagonals of a cube. The cube has side equal to 1 with one corner at the origin. So let us draw this. For example, klaseng ani siya. So let us define now a Cartesian coordinate system wherein so kini siya class ha. Ang pag-set na to sa coordinate system is arbitrary. Pwede ra gid ka mag-assign dira og asa imong x, y, and z, but you have to be consistent along the way. Okay? So for example, this is our z, this is x, this is y. So the cube is somewhat nasa diri sa first octant. So since this is a three-dimensional Cartesian coordinate system, so dili na siya katong quadrant 1, 2, 3, 4 class. This nanatay octant, 8 ka partition. So kini siya, kini diri is the first octant. Okay. So one side of the cube is in the origin. So murag na diri. Hopefully kayo maka-form ko cube class. So, portai lang yun ko ninyo ani. So, I'm gonna magbuhat og cube. Something like this. Cube na ba?
Yes, ma'am.
Cube, ma'am.
Okay. So, we are asked to find the angle between the face diagonals. Like, for example, so, kini. Naatay, pila gani ka faces ang cube? 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Tama ba? 6 faces. Kung tanaw tag ka ng box, mag na siya 6 ra ba class or 8? 1, 2, 3, 4, 6 ra no? 6 faces. So, suppose this is a diagonal. Kining naa siya sa x, z plane. And then the other diagonal nga atong i-consider is kaning na diri sa YZ plane. So this one. Let us redraw it. So naa siya diri. And then the other one is napud siya diri sa YZ plane. Imagine ninyo kung sa kuan pa ni naa siya sa pinakalikod nga part nga diagonal, kinipod siya kay sa iyang tapad nga kilid. And then we are asked to find the angle between these two face diagonals. Kani siya. Kani siya nga theta atong gamiton. Atong gipangita. Okay, so we can actually express our diagonals as vectors. So say for example, this is our vector A, this one is vector B. So vector A can be expressed as a vector with magnitude with components. Pwede siya na to kuan class no. Yang x component kay kini siya no. This one along the x. And then apo siya z component. Wala siya y component kay naaraman siya sa xz plane. So we can write it as since we know that this cube has side equal to 1, then, meaning to say, ang iyang x component di ay is 1x hat, or we can just write it as x hat. Butahan lang na to 1x hat class. Okay, for example, dili 1 ang given nga side sa cube, so you can write any number here. 2 kung unsay side sa imo ang cube. Okay, so you have 1x hat plus wala siya y component because the diagonal here, ani nga face, is just in the xz plane. So you have 0 y hat, or you can just walaon lang, dili na siya nato isulat, pwede ra gihapon gyud. But for the sake of showing you nga na siya tulo ka components, but y component is equal to 0. Ito lang isulat. And then, we have its z component is na diri, no? Ano siya? So, you have 1 z hat. Or z hat lang. And then, for diagonal B, so naa siya sa YZ plane. So, you have naa siya sa YZ plane. So, wala siya x component. So, klaro man po class nga wala siya x component. You have 0 x hat plus 1 y hat plus 1 z hat. Okay, so you have A, B. Now, we are asked to find the angle. So, we can use, ang pinakasayon nga itong pwede gamiton is kini nga relationship. So, we can use this relationship. So, A dot B, the dot product, is equal to AB cosine theta. So, here we can find theta by getting the inverse cosine of, kini siya, no? The dot product of A and B divided by the product of the magnitudes of A and B. So, na-follow na to class?
Yes, ma'am.
Hello?
Yes, ma'am.
So we have this one. Now, we need to know the dot product A dot B. And then we also need to know the magnitude of A and B. Ito ba? The magnitude A and B para ma-multiply nato ang A and B. Okay, so A dot B is equal to, according to the rule, we have to multiply like components. Multiply like components, meaning to say 1 multiplied by 0, 0 multiplied by 1, and then 1 multiplied by 1. Okay, so we have here 1 multiplied by 0 plus 0 multiplied by 1 plus 1 multiplied by 1. So we have here, ilan man sa class? This is equal to 1. Okay, so this is the dot product. Now, how do we get the magnitude of each vectors? So we have this equation class, this one. So from here, we can get the magnitude of A, which is just equal to the square root of A sub x, A sub y, and A sub z squareds. Square root of the squares of A sub x plus A sub y and A sub z. So, so we have A is equal to the square root of A sub x squared plus A sub y squared plus A sub z squared. So we have plus 1 squared plus 0 squared plus 1 squared. So you have square root of 2. Okay? In the same way, we have B is equal to the square root. So this is how we get the magnitude for any vector. This is a three-dimensional vector. So you have B sub x squared plus B sub y squared plus B sub z squared. So we have, I think we will get the same answer. So you have 0 squared plus 1 squared plus 1 squared. So you have square root of 2 also. Therefore, when we multiply A times B, we will get the square root of 2 multiplied by the square root of 2. This is equal to 2. Okay? So let us go back to this equation. We have cosine inverse of, what is this one? A dot B is 1. And then you have A times B is equal to 2. So you have cosine inverse of 1/2. Pila ni siya class? Cosine inverse of 1/2 is 60 degrees. Okay. So this is the angle between the two diagonals of a cube. Okay. So do you have questions? Any questions? Sheila?
Yes, ma'am.
Wala ra may questions?
Wala ra, ma'am.
Okay, so we have lots of examples but unta class. So I will just give this as your practice problem para makaproceed ta sa lahi nga topic. Okay. So let's proceed to the triple products. Triple products. Okay, so sa man triple product class. So there are two types of triple product. Okay, so since the cross product is itself a vector, it can be dotted or crossed to the third vector to form a triple product. So for example, natay gitawag nga scalar triple product. Scalar triple product. Okay, so that is when we get the dot product of a vector and the cross product of two vectors. So, unsa answer ani class? This is, we can get a vector quantity out of this, no? Kung mag-cross product of two vectors, we will get a vector quantity. And then, if we dot it with another vector, we will get a scalar. So that is why it is called a scalar triple product. Now, what is the geometrical meaning of the scalar triple product? Okay. Ang iyang magnitude class is the volume of the parallelepiped. So kung naka-remember mo, kung nakay dot product, sige ito, A dot B, kung nakay duha ka vectors, A dot B for example, you just multiply the magnitude of A by the magnitude or by the projection of the second vector B, for example, the projection of B along A, right? So for the scalar triple product, this one, yung geometrical interpretation or geometrical meaning is that ang iyang magnitude is the volume of the parallelepiped generated by A, B, and C. Okay? So, kini siya class, ang magnitude ni B, the magnitude of B cross C. So, ganun siya. Diba? Ato mong pwedeng na-discuss. The magnitude of B cross C is actually the parallelogram na ma-form out of vectors B and C. So, this one, kini siya, the scalar triple product is the volume of the parallelepiped. So, di ba nakay parallelogram like this. So, this time, three-dimensional na siya. You have a parallelepiped. Okay, so this is a parallelepiped wherein ang iyang base, kini siya, this base is equal to the magnitude of B cross C. Okay? So its magnitude is equal to B cross C, the area of the base. So this is the base. The area of the base is equal to the magnitude of B cross C. Okay, and then this one, the altitude of the parallelepiped, dapat class murag naghirig ni siya, no? Parallelepiped. It depends upon the vector A. So, A cosine theta is actually the height of the parallelepiped. Height of, or the altitude of the parallelepiped. So spelling sa parallelepiped class. Parallelepiped. Okay? So this one. So this height here is equal to A cosine theta. Okay. So from here, from the definition of the dot product, you have, so the scalar triple product A dot B cross C is equal to B dot C cross A, and it is also equal to C dot A cross B. I guess pwede ni siya na to i-show later nga no ingano ni siya. And you have A dot C cross B is equal to B dot C cross A. It's A cross C, sorry. A cross C, and this is equal to C dot D cross A. Okay. Now, in component form class, the scalar triple product A dot B cross C can be written as the determinant of a matrix. We have ang first row is the components of A. So you have AX, AY, AZ. The second row is we have BX, BY, BZ. The third row is the components of C. So we have C sub X, C sub Y, and C sub Z. Okay. Now, take note that for the scalar triple product, the dot product and the cross product, or the dot and the cross can be interchanged. Like for example, A dot B cross C is just equal to A cross B dot with vector C. Okay? So you can interchange the dot and the cross. But take note of this. Kay walay meaning class no kung imo ning ang parenthesis kay ibutang nimo sa A cross parenthesis close and open parenthesis B dot C, because you cannot cross a scalar quantity and a vector quantity. Okay, so take note of the position of the parenthesis. Okay, or you cannot write the parenthesis here. So in this case, in the right hand side of the equation, dili siya nimo pwede butang diri because this has no meaning. A dot B cross with C has no meaning because A dot B is not a vector quantity. Okay? So you can only cross two vector quantities. So let me just erase this one para dito maglibot. Okay? So again, kung i-reiterate no, A dot B, may butangan siya na to parenthesis, and then cross with C, this has no meaning. It has no meaning. Because this one is a scalar quantity. Okay, so how about the vector triple product? So we have the vector triple product. Are you familiar with the backup rule? Okay, so you have A cross B cross C can be simplified by the backup rule. Okay, so it can be simplified by the backup rule. So this means that you have B multiplied by A dot C. Okay, so this is ordinary multiplication. This is multiplication by a scalar. So this is a scalar quantity. Kini siyang nakabutang sa parenthesis class is a scalar quantity. Multiply nato og vector. So this is multiplication by a scalar. We will get a vector quantity. Kini siyang term. Minus C multiplied by A dot B. So this is the back-cab rule. Back minus cab. So the back-cab rule. Now, take note that you cannot rewrite this as A cross B cross C. So this has a different meaning. So kung i-change nimo ang position sa parenthesis, lahi na siyang meaning class because we know that vector product is not commutative, right? So when you change the position of the parenthesis, kung i-change nimo ang parenthesis nimo ibutang sa A cross B, then this has a different meaning with the first one. Okay, so this is different. This is actually equal to minus C cross A cross B. Ito ba? So, dili siya equal ani class. Okay, so you have this one. And then, instead of back-cab rule, kung naadiri yung parenthesis, you have minus A multiplied by B dot C plus B multiplied by A dot C. Okay, so this one. Okay, so dili ni sila equal, no? Not equal. These two are not equal. Not the same. Okay, so I guess na namo proof ani sa inyo ang matfinga notes class. You just have to review it. Okay? So let's proceed to the position, displacement, and separation vectors. So let us define the position, displacement, and separation vectors because we will use these physical quantities often in electromagnetism. Okay, so we know that ang electric field, electric force is dependent on the distance between or the separation vectors between two points nga itong gina-consider. Okay? So let us talk about this. Position, displacement, and separation vectors. Okay, so let us define a point. Okay, so a point in space can be described by a listing in a Cartesian coordinates. So for example, na kay point diri a class like and then you have okay, so this is y, z, x. So na kay point diri as a space anywhere diri ang a space class. So this is a point and we can describe this point by its coordinates. Okay, so x, y, z. So sakto ba? No? So naa siya kung sa Cartesian plane ta, we can represent it as kani siya, a point can be represented by its coordinates x, y, z. Okay. Now, if we draw a line from the origin towards this point here, we can call this the position vector. Kini siya nga line can be called the position vector. Okay, so the red line, we can call it the position vector. It is made from connecting a line from the origin towards the point. Okay, now we let the position vector be equal to r. Okay, So let the position vector be equal to r. So this position vector can be written as x hat plus y hat plus z hat. So it has x, y, and z components equal to x, y, and z. Okay. Now, we can also define a unit vector r hat that is uh, in the direction of the position vector. Okay, so say for example this one, you have a unit vector r hat, which has of course a magnitude equal to 1, and it has direction that is the same as the position vector, so that your position vector r can be written as r. This is the magnitude. Kini siya nga r class. This is the magnitude of r, and then r hat. R hat. Okay? So para ma-visualize na to class, you have this one. So the position vector kay naa siya x, y, and z component. So iyang x, y, z component kay naa siya diri. X. Ang iyang y component kay this one. Y component is this, and then ang yang z component kay this. Okay? So it is a three-dimensional vector with components x, y, and z. Masyaging ani class. Alright. So this is vector r. Now, the magnitude of the position vector r, this one, the magnitude r is equal to the square root of x squared plus y squared plus z squared. Okay? Now, this is the distance from the origin. So when you get the length from the origin towards the point, that is the magnitude of vector r. So the distance from the origin. And r hat, so take a look at this. R hat class from here, from this initial relationship, no, we can see that r hat is equal to vector r divided by the magnitude of r. Okay? So, nakuha ninyo na follow ra class. R hat is equal, or the ratio is equal to the ratio of the vector, the position vector, and its magnitude. Okay. So, if the magnitude of vector r is equal to this, so you have square root of x squared plus y squared plus z squared. Ang iyang the vector r is equal to x hat plus y hat plus z hat. Okay? So this is your vector r, the ratio of the position vector and its magnitude. So it has this form. Now, take note that this is a unit vector that is pointing radially outward. Unit vector pointing radially outward. So if you can recall with your physics 42 nga class, kini si R class kay gamit kini siya, no? For example, the electric field is equal to 1 over 4 pi epsilon naught Q over R squared. Coulomb's law is also dependent on R, the separation distance R. Okay. Now, we can also define the infinitesimal displacement vector, and we can call it dl, or pwede po dr. So we have the infinitesimal, meaning to say very small amount of displacement, infinitesimal displacement, we can, this is from xyz to, say for example, x plus dx. So, kini siya, class. Dugangan lang siya na to gamay nga length along the x. So, na kay x plus dx, y plus dy, z plus dz. So, suppose it is dl. It is also a vector quantity because we're talking about displacement here. So, we can express it as dx x hat plus dy y hat plus dz z hat. Okay, now we can also denote this as dr because sige ito, ang vector r is na siya components nga x, y, and z. So your dl here can also be denoted as dr. Okay, so they are the same. Okay. Now, in electrodynamics class, we often encounter problems involving 2 points. Okay, so nga na to ang mga problems kasagara. It involves 2 points. Okay, so it is important no nga i-define to natong duha ka point. So we have the source point. We can call it R prime. So the source point can be denoted as R prime. And then we have the field point, which can be denoted as R. Okay, so unsa man ni siya class? For example, your source point can be the location of the electric charge. And then ang field point kay the point wherein we want to get the magnitude and we want to get the electric field at that point, or kuha na to ang electric potential ana nga point. So we can call that the field point. So the source point is the position of the electric charge or the location of the electric charge. And then the field point can be the point at which we are calculating the electric field or magnetic field. So nakuha niyo ang difference classes, source point and field point. The point at which we want to calculate the value of the electric field or the magnetic field. Ang sige ng magnetic field, B, no? Okay. Okay pa mo dira, class?
Yes, ma'am.
Okay pa man.
Let me see kung kinsay absent. Si Sheila is with Melchora, no? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wala lagi si Alaini. Wala siya na-inform. Si Bantilan, wala po. Okay, so since we have already defined the source point and the field point, then we can define the separation vector. Okay, so it is dependent on these 2 points, the source point and the field point. So the separation vector, we can denote it as this letter. Kini siya. R gyapon sa class, but pinakinatay nga letter R. So it is a vector. And we can write it mathematically as you have the field point minus the source point. Okay. So it has magnitude. Ang magnitude class, the magnitude of this separation vector R is equal to this one. The magnitude of R minus R prime. And then we define a unit vector, R hat, which is equal to the ratio of the vector and its magnitude. Okay, so we have R minus R prime divided by the magnitude of R minus R prime. Okay. So to visualize, let us draw this one. So for example, naadiri mo ang source point. So again, your source point can be where the electric charge is located. So this is the source point, for example, which is denoted by R prime, no? And then the field point, this is a point where we want to calculate the electric field that is due to this electric charge nga naadiri sa source point or the magnetic field. So this we have here the field point denoted by R. Okay, vector R. Now, the separation vector class is this. Kini siya nga vector. So suppose this kini siya class kay gikan nani siya sa Cartesian plane, for example. So from the origin towards this, towards the source point, muna siya si R prime. And then from the origin towards the field point, this is your R, vector R. The field, From the origin towards the field point, this is your vector R. Kini siya class, the separation vector. This is the separation vector R. Okay? And, ang sige ito, this is equal to R minus R prime. Okay? So, R is equal to R minus R prime. Na-visualize ninyo? Now, in the Cartesian coordinate system, in Cartesian coordinates, we have the separation vector R is equal to X minus X prime. So, suppose si R prime, ang iyang components kay X prime, Y prime, Z prime. Okay? So, you have X minus X prime, X hat, plus Y minus Y prime, Y hat, plus Z minus Z prime, Z hat. Okay? So, kini siya nga vector diri a class na siya ing aning nga components. Okay? How about its magnitude? So, its magnitude is equal to the square root of the squares. So, na kay X minus X prime squared plus Y minus Y prime squared plus Z minus Z prime squared. Okay, no? And then your R hat, you can just divide these two to get R hat. So R hat is equal to, okay, so you just have to divide this. Okay, so let us have one example. And then I guess we will end here, class, because I have an 8:30 class in class 12. Okay, so for example, find the separation vector from the source point. From the source point which has this coordinates 2, 8, 7 to the field point. With coordinates 4, 6, 8. And determine its magnitude and direction. Determine its magnitude and construct the unit vector r prime. So determine the magnitude r and construct the unit vector r hat. Okay, so how do we do this? So since this is the coordinate of the source point, then we have, so itong source point class r prime, no? R prime is equal to 2x hat plus 8y hat plus 7z hat. So this is your r prime. And then for the field point, you have the coordinates 4, 6, 8. So you have r is equal to 4x hat plus 6y hat plus 8 z hat. Okay, so this is your r prime and r. So the separation vector r is equal to, we have x minus x hat. Asa na tong x hat ani class? This is your x. This one is x hat. So, sorry, it's x prime. So you have 4 minus 2 x hat plus 6 minus 8 y hat plus 8 minus 7 z hat. Okay, so this is from initial class, this one. All right, so we can simplify this as 2x hat plus, it's minus minus 2 y hat minus 7, it's minus 1. Minus 1, or you can just write minus z hat. Okay, so that is the separation vector r.
I think positive siya, ma'am, kay 8 minus 7 kay positive 1.
Okay, thank you, Cherry. Okay, so 2x hat minus 2y hat plus z hat. And then next is to find the magnitude of this. So you have r is equal to the square root of the x component, 2 squared plus minus 2 squared plus 1 squared. So this is equal to 4 plus 4, plus 8 plus 1, 9. So you will get square root of 9 equal to 3. So this is the magnitude of the separation vector r. And then finally, we will have the unit vector r hat, which is equal to the vector r divided by its magnitude. So you have 2x hat minus 2y hat plus z hat divided by 3. So this is the unit vector. We can write it as 2/3 x hat minus 2/3 y hat plus 1/3 z hat. Okay? So this is the unit vector r hat. So do you have questions? So in the next
Wala na, ma'am.
meeting, we will have vector transformation. So how vectors are being transformed, and then hopefully we will start with the differential calculus, and then nagtataas tayo ang differential calculus class. Okay, so diri lang sa tataman. I might give you something to work on before this day ends. Okay, and you can submit it in our next meeting. So for the next meeting, we will have face-to-face lang siguro class. Although medyo langan gid ang face-to-face kay dako kay sulatanan ng blackboard. Okay, so do you have questions? Wala na record.
Wala na, ma'am.
None, ma'am.
Okay. So, see you next meeting.
Thank you, ma'am.
Ma'am.
Sige, sige. The recording for this will